Hello, I thought I'd carry on the readings with doing a bit on the saber-toothed cat Homotherium, chapter 3 of the Missing Lynx. And I'll start off on page 78 with a bit about how I've been involved with genetic work looking at saber-toothed cats. The one key question that I've done my utmost to contribute to is that of the phylogeny of the saber-toothed cats. Where do these species sit within the myriad grandeur of the carnivores? We can see from the bones that Smilodon and Homotherium are allied to the cats, but how closely? Are they actually cats, or are they something cat-like? You can think of it like the giant panda. Is it part of the bear family, or just outside looking in? My very first piece of published research looked at this question in Smilodon. My supervisor had heard about bones from a cold cave site at the southern tip of Patagonia, which were stored in a collection in Amsterdam. This was Cueva del Mylodon, or Mylodon Cave, semi-famous for the discovery of the preserved skin of the giant sloth Mylodon darwinii. The beautiful preservation of the skin, with copious red hair, and even small bones embedded within them, like chainmail, was a 19th century sensation. Its apparent freshness encouraged the Daily Express to send a reporter to look for living ground sloths. He didn't find any. The cold, dry conditions of the cave led to excellent preservation, and the bones of Smilodon populator were in amazing shape. My supervisor sampled small chunks of the bone, and one of my first tasks as a scientist was to process the tiny pieces and extract their DNA. We managed to get about 1,000 base pairs, the chemical letters in the alphabet of DNA, from them. In comparison, the Human Genome Project sequenced nearly all of the 3.6 billion base pairs that make a human genome. Still, I felt pretty proud of myself, as our saber-tooth bones were over 11,000 years old. Using this DNA sequence, and comparing it to equivalent sequences from lions, tigers, domestic cats, hyenas and mongooses, allowed us to create a family tree for Smilodon. It's exactly the same kind of analysis that gets done for DNA fingerprinting. We found that Smilodon, and by implication the rest of the saber-tooth subfamily, are about equally distant from all modern cats on a branch to themselves, somewhere between the cats and the hyenas. This was a great answer, giving me my first publication and getting a reasonable amount of press in the national and international media. Very gratifying for the culmination of 3 years' work. The one thing I regretted at the time was that we couldn't get any good DNA from Homotherium to include in the analyses. We had tried pretty hard though. I extracted DNA from many samples of Homotherium from all over North America, but none of them had enough usable sequence for comparison. My love of Homotherium was unrequited. Nonetheless, I put that to the back of my mind and concentrated on other things for the next few years. The issue of Homotherium's phylogeny had to wait. A decade later, I was working on the genetics of lions in Copenhagen. A colleague had sent me some bones from Beringian cave lions, Panthera spelaea, and I was working hard on using new techniques and cutting-edge facilities to get the DNA out. The bones had come fresh from the permafrost, and had been on dry ice from their trip over from Yukon to Denmark. Now, instead of trying to get small, precise fragments of DNA and stitching them together, we had the technology to amplify billions of strands of DNA and use massive computing power to fish out those pieces belonging to the bone. This next-generation technology is fantastic in terms of producing DNA data from old bones, but it now requires that biologists have as much familiarity with programming software as they should with the natural world. Personally, I much prefer spending time in the lab. One of the lion samples I had been sent from Canada proved a bit unusual when it came to analysing the data. I had blagged some basic skills in manipulating the next generation DNA data, and when I was looking at the genome of what should have been a cave lion, something was weird. I focused on a small section of DNA that I was very familiar with, from spending hours upon end staring at a computer screen filled with DNA sequences. Something was wrong. There was a gap. In a living lion, this would have been a death sentence, as the sequence would produce a mutant protein. I recognized it from somewhere else, though. My colleague and friend, Professor Beth Shapiro, who was working at the University of California, had just published a paper that had a small snippet of DNA from a Minnesotan Homotherium bone. They matched. This wasn't an ordinary cave lion bone. It was something much, much rarer and much, much better. We had a permafrost Homotherium bone that had good DNA inside it. In the decade since I first worked on Smilodon DNA, the sequencing technology had improved so much that we now had a real chance of generating a lot of data. And the more data, the more certain we can be of the species tree.